Noon. It is day 27 in geometry. And today it is Wednesday. Let's see, Wednesday, November the 19th. This 19th, okay. And this practice final is your exit ticket for today. However, if any of you are doing a different option than the written final, know that this is not required. What you would do instead is if you're doing the portfolio, you could just show me what you've got put together so far. If you're doing the lesson, you show me your rough draft of a lesson plan. So on here, I'm going to write answer guide. And we're going to get started with number 1. You will need a compass for number 1. So we are constructing the angle bisector. We did a little bit of this yesterday. When I'm trying to construct an angle bisector using a compass, where is the first point I should put my compass on?
The vertex.
The vertex. So I'm going to put the pointy side of my compass right on the vertex, and we're going to draw an arc. So there's my arc. A little messy. Hang on, let me make sure I got that real accurate. I'm going to draw another arc because I didn't like that first one. Point and draw. Okay, I'm going to use my top arc here. Okay, I've got my arc. Where do I go now?
That's where it intersects.
Yes, the points where it intersects. So I'm going to just highlight those points so I don't accidentally put my compass somewhere else. And all we have to do now is draw 2 more arcs from those points inside of the angle. I'll put one here. And from the first arc that we put on the intersection to the second arc, make sure your compass is not open more or less. So if you need to go back and remeasure, it's always a good idea. So I'm going to go back to this one, and there we go. Now, what do I do?
Put a line through it.
Put a line through it. These arcs intersect. That's going to be the point we pass through. So with a ruler or a straight edge item, I'm going to connect the vertex to that final intersection. Draw my ray going through there. And what can I do to show that these 2 angles are the same? The arcs. Yes, we're just gonna, it's all arcs. We're gonna put little arcs in each angle just to show that they are the same. Make your little heart.
Circles.
Yeah. All right. Okay, so that is number 1. We've done it. Now to number 2, we did one like this yesterday also. We have parallel lines and a transversal, what that's called. We have a line going through both lines. So I'm going to use my circle trick here. I'm going to put these 4 angles in a circle and the other 4 angles in a circle. And now that I've got them circled, we want to think about the position of the angles. It says first we want to solve for x and then solve for missing angles. So I'm going to find the angle that has x in it, and it's right here. I'm pointing to it. 2x plus 4. If I want to figure out x, I'm going to need a little more information from one of these 3 angles, B, E, or F. So how can I figure out the measure of any of those angles. Is there anything? Jess, go ahead.
Oh, well, the 78 degrees is across from C.
Ah,
C is gonna be 78 degrees.
C and 78 are the same. They're vertical.
And then,
So that's
so is your
78.
D, it's gonna be 78 degrees as well.
Yes. So
And
these
then-
are across from each other. Let me color them real quick.
The 2x plus
Mhm.
4 is gonna equal 78 as well.
Good. So all of these are 78 degrees. C, D, and 2x plus 4. So now that I have these marked, I could go ahead over here and start labeling my list. C is 78 degrees. D is 78 degrees. And now that I know that, can I solve for x?
Yeah.
I can. What equation would I use?
2x plus 4 equals 78.
Perfect. 2x plus 4 equals 78.
You subtract 4.
Perfect. We'll subtract 4 from both sides.
And then you bring down your 2x equals.
2x equals.
It'll be 74.
That would be 74. Good.
You just divide by 2.
Divide by 2.
Your 2's cancel.
My 2's cancel.
X equals 37.
Perfect. X equals 37. So I've solved for x. Let's fill in number 2. It says x equals 37. Okay, so I have all of these angles that are vertical labeled as 78. I've also found x. How can I find A, B, E, and F?
Like in one of them, A, B, E, or F, you do A plus.
A plus 78 equals 180.
That is what we're gonna do. Why would I do 8 plus 78 is 180?
Because they're parallel lines.
Straight lines are 180 degrees, and I notice here from A and C, we have a straight line. We have 180 degrees. So with that information, let's write an equation and solve for A. So what equation could I write here?
A plus 78 equals 180.
Perfect. A plus 78 equals 180. I'll draw my line.
Subtract 78.
Perfect.
Your 78's canceled. You're gonna bring your 8 equals down. And your 8 equals 102 degrees.
Beautiful. 180 minus 78 is 102. So I know that A is 102. I'm going to fill that in. What else is 102? B,
E, and F.
and all the rest. A and B are 102. And E and F are in the same position as A and B. So they are also 102. Nice. Sounds like that review yesterday helped. We did that one quick. Good. Okay, I'm going to leave that up for a moment, let everyone get it copied down, and then we will move on to page 2. So let me pause this. I think everybody is ready. So let's go to the second page. Now we are going to find the midpoint of the line segment with these given endpoints. So we are going to need our midpoint formula, which we wrote down yesterday. And what is that formula?
X1 X plus X2. Y1 plus Y2.
So here, let me do this. There's the x1 plus x2 and y1 plus y2, but there's one more little thing we need.
The square.
What did they swear on this one? You might be thinking of the distance formula.
Yeah, I'm gonna think about it.
That's okay. What is the other thing we're gonna need?
Divided by 2.
Yeah, divide by 2. So x1 and x2, y1 plus y2, both of them divided by 2. And you may already have that written down, but never a bad idea to write it again. So, once we have our formula, what is a good next step to prepare for this problem?
Label.
Label. Let's label everything. And remember, our coordinates always start with x and then y. So let's make 12 our x1. 2 will be our x2. Negative 8 can be y1. 3 can be y2. Now that everything is labeled, this will help me stay more organized when I plug in my values. So underneath my formula, I'm going to copy it down, but I'm going to leave blanks where I'm plugging things in. So what should I write for the first 2 blanks? 12
12 plus 2.
good plus 2.
And then the second one, you're gonna do negative 8 plus 3.
Perfect. 12 plus 2 and y1 is negative 8 plus y2 is 3. All right. So what do we do from here?
You solve the problem.
Yeah, let's solve the problem. What should I do?
You do 12 plus 2 first.
Okay, 12 plus 2 is
14
14.
divided by 2.
Bring down my divide by 2.
Then your negative 8 plus 3
Mm-hmm.
would be negative 5 divided by 2.
Negative 8 plus 3 gives us negative 5. Bring down, divide by 2.
And you just take both of those and divide them by 2.
Perfect.
14 divided by 2 is 7.
Mm-hmm.
And negative 5 divided by 2 is negative 2.5.
Perfect. 14 divided by 2 is 7. Negative 5 divided by 2 is negative 2.5. And that is our midpoint. So I'm just going to write that in, the blank that I've given you. 7, comma, negative 2.5. And I'll circle it. That is number 4. Looking at number 5. See if you people still doing 4. I'll wait a minute. Same. Yeah, okay. Yeah. Now there's 2 ways that we could do number 5. I'm gonna show you guys a trick today that I may have shown you before, but it's probably been a while. What'd you say?
No, I give them another color.
I know the colors sometimes make it take a little bit longer. That's okay. If anybody at the end wants another copy of the practice
Yes.
final, that way you can go back and rewrite it all nice and neat. Sometimes that's a really good way to study too. I have lots of copies and I can always make more. Does anyone need more time on number 4? Or are we ready for 5? You're still doing 4. Pause it for a second. So now for number 5, we have 2 points on a graph. So there's 2 different ways that we could solve this. Number 1, we could use the distance formula. But before I do that, I want to show you a trick. So notice that since this is on a graph, we've got some lines that we can kind of follow. From point A to point B, there's a distance that we want to find. What if I trace the distance down from point A and make a line, and then over to point B? I have a right triangle now.
5 negative 5.
So what I could do here is I could count the number of the sides. So here's I've got 1, 2, 3. So this side length is 3. This side length, I could count the spaces. 1, 2, 3, 4. That's 4. What do we know how to do to solve for the missing side of a triangle? A right triangle specifically. Don't we have a special formula for that?
Yeah, but there's 2 different formulas.
There is 2 different formulas, isn't there? But what if it's for a right triangle and I already know 2 of my side lengths? The Pythagorean theorem. We could use that, couldn't we? So the trick is the distance formula is actually the same as the Pythagorean theorem. It's just rearranged. So I'm going to show you that. We have A would be like our 3, B could be our 4, and C is the distance we needed. So couldn't I do A squared plus B squared equals C squared? I could. So what would I plug in here? 3 squared plus 4 squared equals, I don't know my C yet, but C squared. So what is 3 squared? 9. Good. And what is 4 squared? 16 equals C squared. That comes down. What could I do now?
Add your 9 plus 16.
9 plus 16, what does that give us? 25 equals C squared.
You're gonna square root both of them.
Square root them. And that gives us C by itself. And what's the square root of 25?
5.
5. So the distance is 5.
Yay.
This is a fun way to do it. It takes a little bit less time. I'm still going to show you the distance formula just in case maybe you feel more comfortable with that. So I've only taken up a little bit of space here. For the distance formula, we need to know the coordinates for A and B. So point A, let's see, what would my X value be for A?
-5.
-5. And my Y value?
It would be +5.
+5. And point B, my X value would be good, -2. My Y,
It would be
1.
+1.
Yeah, +1. So if we want to use the distance formula, we would need to first label our coordinates. And then we'll plug those into the distance formula, which I'm going to give us here again.
Is D equals
Mhm.
the square root of x1 minus x2 Squared plus y1 minus y2 squared.
Good. So I'm gonna zoom in on that now. I'm gonna rewrite what you just told me. X1 minus X2 squared plus Y1 minus Y2 squared. So you're gonna see here, the distance formula takes a little bit longer, which is why I wanted to show you this way too. But it's still good to see both ways. So I have my formula. Let's label our coordinate values. A and B. I'm gonna make A my first coordinate, so -5 can be x1.
-2 to x2.
Yes, -2 would be x2.
And +5 is your y1 and +1 is your y2.
Good. +5 is y1. +1 is y2. Now that everything is labeled, we can plug that all in. So I'm going to rewrite my big square root, parentheses, minus square, plus parentheses, minus square. What would I plug in?
-5 and -2.
Good. -5 minus -2.
And then you're gonna do 5 minus 1.
Good. And then 5 is y1 minus y2 is 1. So, -5 minus -2, what will that give us?
-3.
-3, yeah.
It'll be -3 squared.
Good. -3 squared plus,
That equals 4 squared.
good. 5 minus 1 is 4 squared. What would we do next?
You're gonna the square root of -3.
Yes.
It gives you +9.
Good. -3 times -3, +9, plus, what is 4 squared?
16.
16. Okay, now this is looking familiar because, look at this. When we did the Pythagorean theorem, we ended up doing 9 plus 16, and then we found the square root of that. We're doing the same thing. So what's 9 plus 16?
25.
25. And the square root of 25? 5. So my distance is 5. It's the exact same answer. Same thing. It just takes a lot longer and it's more steps. So, if you feel comfortable counting the sides and turning this into a triangle, that Pythagorean theorem might be a little easier. If you're more used to using the distance formula, you can do it that way too. Both ways are perfectly correct. You just have more steps for the distance formula. Okay, that was a lot of writing. I'm going to pause this and let everybody get caught up. When you are ready to move on to number 6, or if you have any questions, you can raise your hand. Give me a thumbs up if you're ready to move on. Okay, so everybody's ready. Number 6 and number 7. These, we are using the triangle inequality theorem. I've given you 3 different side lengths, and the question is, could these side lengths be a triangle? You need to show your work, and then you circle yes or no. If you don't show your work, I cannot give you full credit because you've got a 50-50 chance of circling yes or no correctly. I need to see how you pick yes or no. So, this is the one where we want to find the biggest number, circle it, add the other 2 together, and see if, yes. So for number 6, what is my longest side?
42 inches.
42 inches. I'm going to circle that.
Let's see.
And let's see. My other 2 sides, what do I do with them?
Add them together.
Add them. Good. So 23 plus 21
Is 44.
is 44. So we ask ourselves, is 44 greater than 42?
Yes.
Yes. So the answer is yes. Not so bad.
It could be some greater, obviously.
What helps me,
I literally had to write it, big letters on the bottom of my book.
here's what helps me. I like to think of my greater than symbol as a hungry alligator. And the hungry alligator wants to eat the bigger number. So he's going to face towards the greater number, which is 42. 42 is greater than, or 44 is greater than 42. Yeah. So that's my little trick. My hungry alligator. Okay, so for number 7, what's my largest side?
38.
38.
17.
Good. 5 and 12 make 17. So is 17 greater than 38?
No.
No. It is not. So is it a triangle?
Nope.
No. Not true. Perfect. That is all of page 2. When you are ready to go to page 3, give me a thumbs up and we will move on. Okay, Melena's ready, Riley's ready, Kelsey's ready, Seth is ready, Jacqueline is ready, Lisa's ready, Jess is ready. Nita is ready. Perfect. Okay, moving on to page 3. Special right triangles. Okay. So I have, for number 8, a 45, 45, 90 special right triangle. Let's label our x values. We have been given BC, 18 inches. From B to C, what x value does this have?
Yeah.
That's my x. What else is x?
AB.
Good. And what is my hypotenuse AC?
X vertical 2.
Yes. X radical 2. So I'm going to label my little things down here as well. BC is 18, BC is X. So 18 is X.
AB would be
AB,
18 too.
yes. AB is also X, and you know X is 18. AC, I'm going to write that X radical 2. And Holly, you're exactly right. If AB and BC are both X, and this one's 18, then AB must also be 18.
Don't forget inches.
Ooh, thank you. Inches. So I know that X is 18. I know that AB and BC are 18. How am I going to find AC?
Plug it in.
Plug it in. If X is 18, and I want to find x radical 2. We're going to replace x with 18. 18 radical 2. So we're going to type that in.
25.45.
So second x squared gives me my square root, but I did that too soon. I should write 18 first, and now second square root 2.
25.45.
Perfect. 25.45. If we were going to round up, we might put 46. If you put 45, it will still be correct. So 25 point, I'm going to put 46 since there's a 5 afterwards.
You do 0.4.
You could do 0.4. That would be fine with me. So 25.46 inches. Perfect. That is number 8. So make sure that you write down those x values so that you have them available on your final. And now that we've got number 8, we're going to look at number 9, and that's a different kind of special right triangle. Yes, thank you, 30, 60, 90. So we're going to have different x values. You have been given that DE is 31 inches. I'm going to label that on my triangle also. Here's DE, that's 31. And then what x values am I going to write down here?
That's gonna be your X.
What's my x?
E to F.
E to F, good, that's x. I'm going to label that down here too.
Your 31 inches is gonna be your X radical 3.
Yes, DE or 31 is x radical 3.
And then D to F is 2X.
Good, and D to F is 2x. So, for number 8, I was given my x value. I didn't have to find it. But this time I'm not being given an x value. So, we need to write an equation to solve for x. What would that equation be? It's already up here. Yes, 31 equals x radical 3. So let's do that. I'm going to circle this to help me remember that's where I got it from. 31 equals x times radical 3. How do I get x by itself here? Yes, divide by radical 3. Divide by radical 3. We'll cancel. I've got x all by itself. And I'm going to type that in. 31 divided by second radical or square root of 3. Enter. I got 17.897858834. You guys getting the same number? Good, good. See, you shake your heads. Good. So I am going to make that, you could do 17.8, you could do 17.9, you could do 17.89, you could do 17.90. It might vary by a decimal or two, but that is just fine. I'll keep that into account. When I grade your finals, I'm not going to be picky. So I'm going to go with 17 point, I'll do 89, I guess, even though that's not rounding it. So now I have x. How can I use this to find my other side? So I'm going to plug it in. So let's see. What should I plug that into?
2 times the 17.
Yeah, this is 2 times x for VF. X is 17.89, so VF equals 2 times x instead of x, 17.89. And that gives us
35.78.
35.78. Perfect.
Yeah.
Good. 35.78 inches.
So saying inches.
Yes, yes. So this is okay, so I've got that for VF. How do I find EF?
X is, uh, 0.78, right? It's just divided in half.
You could divide that by 2 if you wanted. Or there's an even easier way.
It's 17 point.
It's 17.89.
Yeah.
EF is X, and we already know X. So
17.89.
EF is 17.89 inches. There we go. Make it good. Pause it there, let everyone catch up. And when you're ready for the next question, which I forgot to label a number, that is supposed to be number 10.
Uh-oh.
Whoopsie. When you're ready for number 10, give me a thumbs up. So for number 10, we are using the Pythagorean theorem again. We're solving for x. The hardest part of this problem is making sure you know which side is A, B, and which side is C. So I know we're going to use A squared plus B squared equals C squared. Which side length has to be C?
Your egg.
My X?
The longest side is 12 feet.
The longest
Oh,
side. Ooh. So remember, the longest side is always across from 90. Always across from 90. So 12 is our longest side. That's C.
X is A.
X can be A. 8 can be B. Good. So let's plug those in. A, good, X squared plus B 8 squared equals
12 squared.
C is 12, so 12 squared. Good. And now that everything's plugged in, how do we solve this?
You square your 80 and your
Yes.
12.
So 8 and 8 went to the store.
64.
They bought it into the 64. Okay. That's our 64. And
12 times 12 is 144.
perfect. 12 times 12 is 144.
You bring down your plus x squared.
Good. Let's bring everything else down. X squared and plus.
And then you subtract by 64.
Perfect. Subtract 64 from both sides. Good. Bring down x squared equals
80.
80. Minus 64. Yes, that is 80.
Then you just square root both of them.
Perfect. All you do is find the square root of both sides. So square root of x squared is 6x. And the square root of 80,
8.94.
Yes. 8.94. And what are our units this time?
Feet.
Feet. Good. So I'm going to write here, it says find x equals 8.94 feet. Yes.
That accidentally make it look like.
That's okay. I feel like my decimals always look like a comma. Cause,
When it gets to a really big after a really small number, that's when it gets.
right, it can
It
be
looks like you put
confusing.
valid.
All right, let's go to page 4. And now we are back to quadrilaterals. So for this page, number 11 and 12, we are finding the perimeter, the area, and we're deciding what type of quadrilateral we're looking at. So we took some notes about this yesterday to help us remember. This is kind of the guide that we made. So that should be in your notes from yesterday again. So starting with number 11 here, before we even do perimeter and area, what type of quadrilateral is this? Oh, you're so close. It is a rhombus. It's a rhombus. Now, it's a rhombus because all four sides are the same. Yes.
So it's also just squished.
Yeah, rhombus is kind of squished because it's just a tilted square. That's really all it is.
Also, it's a diamond if you know that.
Yeah, it's like a diamond. So rhombus. Okay, and let's also name the type for number 12.
It's a rectangle.
It's a rectangle. Good. Okay, so I have my heights. Now, for perimeter of number 11, what formula will we use?
The 2 times base of both sides.
Good. Perimeter
In this
is
case, your height is your base.
C2 and times base plus side. And before we plug stuff in, let's really go through and label everything. 55 inches, what does that
Your
represent?
side.
That's my side. I don't see a base.
But it'll be the height.
Yeah. Now be careful, it won't be the same as the height, because this is our height here. And the height is 48 inches, but our side has 1 tick mark. The base also has 1 tick mark. So they're the same. So our base is actually the same as the side here. It's 55 inches. Does that make sense how we got that? Yes. Okay. So let's plug those in. P equals 2 times my base is 55 plus my side is 55.
Of 10, that would be 55 plus 55.
Okay, so those give us 110 when I add them together. I'll bring down my times 2. You could also distribute to find this. You'll get the same answer.
It'll be 200 or 220.
Good. P equals
220 inches.
220 inches. Beautiful. So my perimeter is 220 inches. Okay. So
Do area.
now we do area.
Area equals base times height.
Good. Area equals base times height. So I already know my base is 55. What's my height?
48.
48. Height. So,
Take 55 times 48.
perfect. Plug them in. 55 times 48.
And then that equals 2640.
2640.
Inches squared.
Perfect. Yes, 55 times 48 is 2,640. And you're correct, it is inches squared. 2,640 inches squared. Good. Wow. Wow, wow, wow. So smart, you guys. Now for number 12, we can use the same formulas, which is nice. I'm going to highlight these formulas so I don't have to go searching for them later. There's my perimeter, there's my area. So for our rectangle here, what is my base?
82.
82. What's my side?
31.5.
Good. Base is 82, side is 31.5. And let's start with perimeter. So P equals, what should I write?
You're 82 plus 31.5.
Okay, so we're
Or 2.
Yes, 2 times 82 plus 31.5.
You add the parentheses because
Good. Add what's in parentheses.
it gives you 113.5.
Perfect. 82 plus 31.5 gets us 113.5. What comes down?
The 2.
The 2. Perfect.
227.
27. P equals 227 units.
Inches.
Inches. Good. This time, what is my height gonna be?
31.
It's the same as the side this time. Now, why are we able to make it the same this time, but we couldn't for number 11?
Because number 11 already had a height.
Number 11 already had a height.
Is that like an angle? Yes.
Yes, and it's at an angle. The sides are at a weird angle on number 11. On number 12, our side is at a 90-degree angle. Our height has to be at a 90-degree angle. So that's why this can be our height, 31.5. So now that we know that, how do we find our area?
You're going to take 82 times 31.5.
Good. 82 times 31.5.
And it gives you 2,583.
2,583. That's big.
It'll be inches squared.
Good. Inches squared. Okay. So double checked it. That is correct. 2,583. 2,583 inches squared. Very good. Okay. Yes. That is smart. So I'm gonna repeat what you just said, Seth. Seth has a good idea to help you remember certain things. For number 11 and 12 in the directions, it says that we are finding the area and perimeter of a quadrilateral. So Seth highlighted that so that when you look back at your notes, you know you're looking for quadrilateral formulas.
My regular.
Yes. Right. And then for number 13 and 14, the directions say we're using regular polygon formulas. So that's another great thing to highlight. Just to make it stand out a little more and help you remember. You can always write anything in the world you want on these practice quizzes and practice finals. If it's going to help you, it's a good idea. leave that where we can still kind of see it. And now we need our regular polygon formulas. So what is our perimeter formula for this?
P equals number.
And sides, sides.
Good. Perimeter is N, or the number of sides, times S, or the side length. And then area
Is the perimeter
So papa.
Awesome.
divided by 2.
Divide by 2. Good. Highlight those formulas as well. So they're easy to find later. For number 13, let's see. How many sides do I have for number 13?
5.
5. Good. It might feel silly, but it's really not a bad idea to go through and actually count. 1, 2, 3, 4, 5. 5 sides. So N is 5 for number 13.
And then your side length is 28.
Good. And our side length is over here, 28. And just to have it labeled as well, what is my apothem?
36 inches.
36. So 36. I've got it all to the side now. So let's do perimeter first. E equals, what should I multiply?
5 times 28.
Yes, 5 times 28. And let's see.
It'd be 140
140.
inches.
Good, and that is inches. Wonderful. 140 inches. Now that I have my perimeter, we can find our area. So let's do A equals, what am I writing? 140, good,
Divided by 2.
good, times 36 divided by 2.
Your 140 times 36 is 50, 40.
Okay, so A is, say that one more time, 140 times 36 is
50, 40.
perfect, 5040.
And you just take the 5040, divide that by 2,
Mm-hmm,
and then you get 2520
perfect.
inches squared.
520 inches squared, 2520 inches squared. What type of polygon is this?
Pentagon.
Pentagon. Good. No, it's a pentagon because it has 5 sides. Good. Okay, same exact thing for number 14, just different numbers and a different shape. Same formulas. Let's start by counting our sides. See how many we have.
There's 10.
There's 10?
Yeah.
I'm sure you're right. I'm gonna double check just to be safe. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Good. Good. So 10. That means in my number of sides is 10. What did you say? Cannibal? Was Cannibal Lecter?
Fish series.
I think I may have seen a little
One of
bit.
the characters that's. That's not what this one kind of thing is.
Huh. Oh my gosh. Okay, n equals 10. What's my side length?
12 inches.
Good. So S is 12. And my apothem,
23.5.
23.5. So we've got all those numbers pulled out. Use them.
You're gonna take 10 times 12.
Good. P is the number of sides times the side length. So 10 times 12.
That's 120.
Perfect. So my perimeter is 120.
And then to find your area, you're gonna take 120 times 23.5 divided by 2.
Perfect. So I'm going to go ahead and write in perimeter is 120 inches. Now we're going to go and use that to help us find the area. And what you just said, Jess, is perfect. We're going to take perimeter 120 times a bottom 23.5. Divide that by 2.
Your 120 times 23.5 gives you 2820.
Perfect. So that is 2820.
And then you take that divided by 2.
Mm,
And your area equals 1410 inches squared.
perfect. 1410 is my area, and it is inches squared. 0 inches squared. What type of polygon is this?
Decagon.
Decagon. Good. All right. We just have 2 questions left.
Yay.
Other than the bonus, of course. Just a second, let everybody finish, and then we'll go to the last page. Let's go to page 5, last page. And on this page, the last 2 questions have circles. You're going to find the area and the circumference. And you're also going to label the diameter and the radius. Once we get done with that, there is a bonus question, which we will go overlap. So, for number 15, I've been given a length in my circle, and it's been labeled with 45 inches. Is this a diameter or a radius?
Diameter.
That's a diameter. Something that I like to do that always helps me remember is if I can draw that line down the middle and I trace around one side here, it makes a D for diameter. So this is a diameter, 45 inches. So now that I have my diameter, how do I find my radius?
Divided by 2.
Divide it by 2. So radius is 45 divided by 2.
It'll be 22.5.
Good. 22.5. So my radius is 22.5 inches. We need our area formula.
Pi times radius squared.
Good. Area equals pi times radius squared. I'm going to highlight that. Which number do I plug in to find area?
The 22.5.
Yes. Area equals pi. My radius is 22.5 squared. And we just type that in all at once. So, if you use pi on your calculator again, second blue button and the up arrow right above your division symbol.
You took it at 1590.43.
All right, let's see. So pi 22.5 squared 1590.43
Good at 8 inches squared.
inches squared. Good, 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 good. So we got 5904.3, and that's correct. It is inches squared. 1590.43 inches squared. The only one that's inches squared is area. Everything else is inches. So if that's something you might find yourself getting mixed up on, you could also label all of these inches, inches, inches squared. Circumference is inches. Area is the only different one. Now that we have our area, we need a formula to find circumference as well.
There's 2 different formulas for circle.
Okay, 2 different formulas. What's one of them?
2 times pi times radius.
2 pi radius or
Pi times diameter.
good, or pi times diameter. Both of them will work. I usually like to use the diameter one because it's often less numbers to type in. But the other one works just as well. So, circumference equals,
141.37.
girl, yeah. Let's type this in. Pi times, I'm going to use that second formula, 45 for diameter. Yeah. 45, enter, I got 141.37. Okay. So that's it. 141.37 inches. Good. Almost done. One more. Okay. For number 16, I've been given a measurement of 21 inches. Is that a radius or a diameter?
Radius.
Radius. Since I can't go all the way up and make a big D for diameter, I can do a little R for radius. That's my other trick. So if my radius is 21 inches, how do I find diameter?
Times the 2 times
Times
the radius.
2. Yes. So to find diameter, we take radius times 2. 21 times 2.
It'll be 42 inches.
Perfect, which is 42 inches. We can use these numbers to find circumference and area.
The area formula would be pi times 21 squared.
Good. I 21 squared. 21.
It'd be 1385.44.
1385.44
Inches squared.
inches squared. Four inches squared. Last but not least, circumference.
You could just do the easiest one, the pi times diameter.
Yeah, let's do that. Pi times diameter. So which number?
42,
42.
and you get 131.94. If you wanted to round it up, it'd be 95.
You are correct. 131.946. So we could round it up to 95. E equals 131.95
And no feet.
inches. All right. Okay. So that is all of the required questions for the final. We are also going to go over this bonus point question. If you know that you're not going to want to do the bonus, because you don't have to, this is a great time to take a break, bathroom drink if you need it. If not, we're going to power through and finish this bonus real quick. After the bonus, I'm going to run and make copies of the actual final exam. So if any of you want to start on it today, you absolutely can do that. So, I'll leave this up for a second. Let everybody finish writing, and we'll do the bonus. Here. So, moving down. Bonus. It says, find the total area and perimeter of the combined shape. The shape is composed of a rectangle and two congruent means equal, means they're the same. So two equal halves of a circle. You have an idea? What's your idea?
Really good circle. A square.
Yep,
So regular.
you're totally correct. This right here, these two half circles, if I were to put them together, it would just make a circle. So here's what I'm going to do. I am going to kind of outline my circle halves. I'm going to pull them out.
What make you think about it?
What made me think about this?
Mm.
Like what made me come up with the
Hmm.
question?
Yeah.
I don't know. I just thought, how can I make a bonus question that we haven't done? Something different.
They're at nice, like,
And you know what? This is something that you might use in your real life. Because what if I want to know how big a room is or something, and I don't know, like it's a weird shape that's made up of multiple shapes.
you mean like my
Um,
living room?
Yeah. Like what if I had a room that was shaped like this, and I wanted to know the area of the room? I can't find the area of a shape like this because I don't have a formula. So I would need to split it into multiple shapes, find the area of this and that, and add them together. So this is something you may use, you don't know. Maybe not. Usually the builder tells you that on their plans. But just for fun. Okay, so I'm going to pull these out. And I'm going to make
180 or 80
a circle. What's 180?
circle.
360.
Oh, it's not 360.
The angle,
Half of
yeah,
it's
it makes a
180.
full 360 degrees, but we're not worried about degrees here, actually.
We don't need that, do we?
Don't need what?
We
The
don't.
300.
You don't need the 360 for this problem, but we do need to know that this is a circle. Because now, what I'm going to do is I'm going to draw a line through it to show I put these two together. And if I want to find the area or the circumference of a circle, I need a measurement here. If I look at my picture,
It'd be 45.6 inches.
yes. So right here, I see this is labeled 45.6 inches.
So that would be your diameter.
So that would be my diameter. Yes. This is
Gotcha.
45.6. That's my diameter. Okay. So I have that. So that helps me find circumference. But if I want to find my area, I need my radius also. So if I know that the diameter is 45.6, how do I find the radius?
Divide that by two.
Just divide it by 2. Yeah, so 45.6 divided by 2. Radius is
92.8.
22.8. Okay. So we're gonna find, I'm gonna color this in. We're finding the area of this part of our combined shape. Let's find the area first. Area equals, what can I do?
So you do pi times radius squared.
Pi radius squared, so we'll use that 22.8. And one of you get an answer, tell me what it is.
Do 1.62.
71.62. What did you type in to get that?
Oh, I forgot to make the square.
Oh, that would do it.
I got 1633.12.
Good. Area is 1633.12, or you could put 0.13, either one. I'll do 12 because you said it. So, and I'm also going to kind of label over here that this is my circle area. So I don't mix things up. And that is, thank you, Jacqueline, that's inches squared.
Right in here, go.
So that's my circle area. But I want to know the area of the whole shape. So I also need to find the area of this rectangle, don't I? Yeah. So let's see. Rectangle area. To find the area of a rectangle, I need a base and a height, don't I?
Yeah. The base is 50.
Base is 50.
The height is 5.6.
The height is 45.6. Okay, so rectangle area. What will we do with those numbers?
So base times 50.
Yes, base times height. So 50 times 45.6. Tell me when you get an answer.
2,280.
Perfect. Our area is 2,280 inches square. Okay. So I'm going to highlight the 2 areas I just found. I found the area of my rectangle. I found the area of my circle. How do I find the area of those combined? Just add them together. Yes, add them together. So,
That's interesting.
now I'm going to write 1633.12 plus 2280. Nothing. I'm gonna do the old fashioned one. 2 plus 0 is 2. 1 plus 0 is 1. 3 plus 0 is 3. 3 plus 8 is 7. Carry the 1. 6 plus 2 is 8, 9. 1 plus 2. 3. If you typed it in, tell me, are you getting the same answer as me?
391. 13.
Perfect. 3913.12.
That's wrong.
Good.
It's 3,913.
That is our area of the whole shape. Look at
I
that.
gotta get perimeter.
So 39.12. Oh, that was not right. I don't know what I'm writing. Area is 3913.12. 3913.12. What are my units?
Inch squared.
Inches square. Good.
I have a question.
Yes.
So does that mean the circle it would be circumference plus the whatever the perimeter of the triangle is?
Yes, almost. Almost. We are going to use the circumference because the whole circle is the outside of the shape. But whenever we do perimeter, we only include the outside of the combined shape. So, are these lengths outside of the shape? Because the perimeter, I'm going to highlight what the perimeter includes. Perimeter only includes the outside. So only what I highlighted. So am I going to use the height here? No. I'm going to use these, like the base and the opposite side that's equal, because it's on the outside. Perimeter is only the outer edge. So we will use circumference because the whole outer edge of the circle is outside. But we won't have to find the whole perimeter of our rectangle.
50.
Yeah, we're just going to add that 50 2 times because there's 2 of them. So let's see. Let's find the circumference of our circle. C equals, what did I do?
Equals 2 pi.
2 pi times, if you do the 2, we would use radius. If you want to do diameter, wouldn't use the 2.
45.
Yeah. So we would just do pi diameter. Diameter or pi 45.6. Yes.
So it'd be 143.45.
Yes. 143.256625. So we can do 25 or you can round up to 6. 143.25. And that was this part. We did the circumference of the circle.
So then we just add the 50.
Yeah, and then we add, there's 150 to add, and then, is that the whole perimeter? Another
That's
50.
50.
Yeah, so you're adding 100 altogether. So we have our circumference. So I'm going to write down here for perimeter, we need circumference plus the 50 plus the other 50. So
143.25.
plus 100 basically, yeah.
It'd be 243.25.
Yes, 243.25. Yes, and that's inches. And that is it. That's the bonus. So, if on your final, maybe you have a similar question but slightly different shape, for example, like let's say there was something like this. Let's say there was like a square or something in the middle. And then like two triangles maybe.
That's awful.
If I had something like this,
Oh my god.
it's the same thing. It's just now you're not using circle formulas.
It'd just be the triangle.
Yes,
Yeah.
you're using like triangle area. And then for perimeter, I would recommend do the same thing. Highlight just the outside of the shade and just add the sides that touch what you highlighted. Only add this side, this side, this side, this side, this side, this side. Don't
Yeah, so
include
say
what's
like-
on the inside.
Say like the squares are the square sides, so they're both 50.
Yes.
And then this 160 and the other's 30.
Right.
You just add all that up together.
Yep. You just add it all together. Perimeter, if you ever don't know the formula, it is add the sides together. That's it. Add all the sides together. Okay. That is our practice final. Yay. So I am going to leave this up and I'm going to go run copies of the actual final exam for anybody that may want to try it today. If not, you're free to go. You can wait till tomorrow with everybody else, or you can stay, completely up to you. I'm going to end that recording.